All right, guys, we've got one more video with solving systems, and that is some systems word problems, okay? And like I've done with word problems before, I'm going to do these on a worksheet and a little bit in Desmos too. So we're going to move over to that right now.
All right, everybody, we are here in Desmos, and I got some example problems up here of some systems word problems. And so with these problems, we have to do a couple things. We have to organize, right? We have two different equations that we have to have, right? Because systems of equations have two different equations, and they also are going to have two different variables. So that's what I'm going to do first, is I'm going to define my two variables, and I'm always going to use the letters x and y. Okay, and I'll explain why in a second. Um, but yeah, that's the normal letters that we use, so you're probably used to that. But again, so let's just read through this first one. Okay, so it says two teachers buy brownies and sodas for their students. Wow, how nice is that? The first teacher bought 30 brownies and 24 drinks, it should say sodas, and spent $48. The second teacher bought 20 brownies and 12 sodas and spent $28. And so it wants us to find the price of the brownies and the sodas. Okay, so that's the situation. Okay, so again, we're given all this information about these two teachers and how much they spent total. Okay, but the unknown amount, right, because all word problems have some unknown amount that we're trying to find. It says find the price of the brownies and the soda. So that would be like an individual brownie and an individual soda. We don't know the price of those, right? The brownies could be like $1 or $2 or whatever. The soda, same thing. So those are going to be my two variables, right? The cost of a brownie is going to be X, and then the cost of a soda is going to be Y, right? Like an individual brownie and a soda. Okay. So I know that, okay, and I can kind of organize my two equations around that, okay? And so again, what I have to do is I have to take these equations that are these statements that I'm given about these teachers, and I have to make them into math equations using these variables, okay? So the first teacher, let's talk about what they spent, right? So this teacher bought 30 brownies and 24 drinks and spent $48 total, okay? So again, it's like we've done before with word problems too. It's helpful to associate, right? If they bought 30 brownies total, right? The amount that they spent just on brownies, we could represent with 30 times x, with x being the cost of an individual brownie. So that is how we, right? So like if just for brownies, if brownies were $2, right, we would do, okay, the 30 brownies that she bought times $2 each would be $60, and that would be obviously more than she spent, so it's not $2. But yeah, so we can represent that with 30x. Okay, and then something else that she bought to add to this total is these 24 drinks, right? And again, these sodas. And we don't know how much an individual soda costs, but right, we could say similarly it's 30x plus 24y, right? Because just the amount that she spent on sodas would be 24, right? She bought 24 of them times the amount that they cost individually. Okay, and those two amounts add to that $48 total that she spent. Okay, so that's it's you can see that it's a pretty it goes right in order like how they list it in the statement there. Okay, about that teacher. And so then the second teacher, we could also say kind of similarly, right? We could say 20 brownies, right? So that would be 20x plus 12 sodas, so that would be 12y equals the $28 total that they spent. Those are going to be my two equations, and that's the setup there. And I might have done that quickly, and you might be saying, oh, that looks easy. But this is probably the hardest part of the process, is setting up these equations from the statements that they give you. Okay. Now we have a couple options of how we could solve this. Okay, I have Desmos open over here to the side, and I'm going to use that to solve every other problem. Okay, but I just wanted to show you how to do one of these by hand, okay, or solving it without a calculator, just in case you would be asked for that. Okay, so again, I showed you guys the three different strategies for solving a system, right? And so that would be by graphing, right? And we're not going to do that here. By substitution and by elimination. Okay, so out of substitution and elimination, we kind of have our option here of whichever strategy we want. And so we look at the equations, and again, if a variable was just by itself, so if said like x plus 12y equals 28, we could solve that with substitution by getting the x by itself and then replacing the group in the other equation with that. But that might be difficult here, so instead I'm going to do elimination. Okay, I'm going to add my two equations together, right, and hopefully one of these cancels out. But again, with elimination, what I would need is to have two of like the same variable, so either both x's or both y's. I need them to be like inverses of each other. So like if this is 30x, I would want this to be negative 30x. Or if this is 24y, I would want this to be negative 24y. Okay, and you can see neither of those are that way right now. But specifically with the y's, I could easily make this into 24y, right? We talked about how you can multiply a whole group times something, right? So if I wanted to make this into negative 24y, I could multiply it by negative 2, right? Because 12 times negative 2 is negative 24, okay? But again, I can't just multiply a single term. I have to multiply the entire group, okay? So I'm basically going to distribute a negative 2 to all three of these terms, okay? And so just rewriting my two equations then after I do that, my top one's going to stay the same, so 30x plus 24y equals that 48, so that's going to stay the same. But if I multiply that bottom group, right, negative 2 times the 20x would give me a negative 40x, okay. 12y times negative 2 gives me the negative 24y that I need. And then 28 times negative 2 gives me a negative 56, okay. So now that I have that organized this way, I can do elimination. I can add my two equations together. So if I added these, 30x plus negative 40x would give me that, or give me negative 10x, okay? And then if I added 24y plus negative 24y, right, that would be 0y, thus canceling these out, and that's what I want to happen, right? And then if I added 48 plus negative 56, that would equal negative 8. Okay, so this is what I'm left with here, okay? And yeah, so now I'm ready to solve this for x, okay? And you might be saying, it's a negative. Word problems usually aren't negative answers. And don't worry, that this will end up canceling, right? Because if I try to get the x by itself, I would divide both sides by this negative 10, right? Divide by negative 10, divide by negative 10. And so that negative 10 would cancel here. So then if I do that division, I would be left with x equals negative 8 divided by negative 10. Okay, and you get a decimal there. You get positive 0.8, right? Because the negative divided by negative is positive, right? So think about that. X equals 0.8. You might be saying, oh, a decimal. Why? That probably isn't right. But it is right in this case, because think about this. X, what does X represent? X represents the cost of a brownie. Can you have a decimal cost? Yeah, you can, right? Because that would be like $0.80, right? And think about it. That would be a realistic price for a brownie. That's what I just found. 80 cents is how much a brownie costs, right? So there we go. And you might, and a lot of kids at this point think, okay, I'm done. I found my X. I'm good. But again, I need to find X and Y. Okay. So now that you found X, finding Y is a lot easier, right? Because what you do is, because you remember with all the other strategies that we did, I take one of my original equations. So if I take this original equation, I'm going to substitute in that 0.8 for the X. Okay. So 30 times 0.8 plus 24y equals, so that's what I'm left with here, okay? And so now I can kind of solve this out, right? So 30 times 0.8 ends up being 24, okay? So 24 plus 24y equals 48. So then if I was to minus this 24 from both sides, I would be left with 24y equals 48 minus 24 would just be 24, right? So 24 times y equals 24, okay? I would divide both sides by that 24. The 24's on the left cancel, and 24 divided by 24 is just 1, okay? So y equals 1, and again, think about that. Cost of a soda is 1, so that would be $1. Okay. So my answer to this question would be, again, kind of writing it as an ordered pair, it would be, you don't need a dollar sign, but it would be 0.8, comma 1. Okay, the x value is 0.8, the y value is 1. So that would be it. Okay, that would be the setup of this, and again, that's doing it by hand. Now, I'm going to go on to another one. I'm going to skip over Joey and his Shakespeare play here, and I'm going to go over this guy right here. Okay, and so that's doing it by hand, but thankfully, you guys have this tool right here, Desmos, and you don't need necessarily to do it by hand all the time. Okay, so let's look at this guy here. Okay, we're talking about Ike with his funny name and his change. So Ike dumps out his change jar. He has a total of 93 coins, all nickels and dimes. The total value is $7.45, and it's asking how many nickels does he have. Okay, and so here's something. Okay, here's with this problem, here's something that we need to keep in mind. Okay, usually, again, after we read through the problem, we look at the question at the end, and that's going to determine what my x and y values are, like what they're going to represent. Okay, so in this case, it just asks how many nickels that he has. Okay, and it doesn't ask about dimes, even though it also says he has a certain amount of dimes. So even though it's just asking for nickels in this case, and let's just say x is going to be the number of nickels, even though, so when x is number of nickels, y is going to be the number of dimes as well. Even though we don't know, or it's not, the answer isn't necessarily going to be concerned with the number of dimes that he has, I would need to know that in this case. Okay. Okay, so again, thinking about setting up my two equations. Okay. So I have two statements here, and it's a little bit less clear than the last one was about how I would get the two statements, right? The first one was nice, where each statement was kind of an equation. And this problem here, the second, like each statement is going to be its own equation, but it's less clear with how I would organize those. Okay, so let's think about this. Okay, so he has a total of 93 coins. Okay. So let's think about that. Again, usually we put total amounts when we have an equation. Usually those total amounts go at the end, right? And that's going to be true in this case as well. That it's going to be, this equation is going to be something, something, something equals 93. Okay, that's going to be the total. And so again, think about what don't we know in this problem. We don't know how many of each individual coin that he has, right? So he has a pile of nickels and a pile of dimes. Again, for us, we don't know how many of each that he has, but we know that the total of the nickels and dimes added together is 93. Okay, so setting up this equation, okay, so my two unknown amounts are going to be kind of adding to this total of 93. Because if x is the number of nickels, again, it could be 40 or 50. We don't know how many exact nickels that he has, but we just know that he has some amount of nickels, and again, we know he has some amount of dimes, but we just know that those amounts are going to add to give you that 93 total that he has. Okay, so that is the first equation, just x plus y equals 93. And now for my second equation, okay, look, the other number I didn't use in here is $7.45. Okay, so that is going to be another total that I have, right? $7.45. So again, think about this. Again, what don't I know in this situation? I don't know how many nickels and how many dimes he has. I know that he has 30 or 93 total coins, and I know that the value, right, if he added up the value of all those coins, he would have $7.45. Okay. So again, there's a missing amount in this problem that is not explicitly shown to me, like in numbers, but would be implied. Okay. So think about this. Again, we know, what do we know about nickels and dimes? We know that a nickel, right, they're both coins, but they both have a certain amount to them, right? So a nickel is worth how much? A nickel is worth 5 cents. Okay, and again, a lot of kids would just say that as like 5. Okay, but think about it in terms of, all right, this total amount is given to me as dollars, right? $7.45 or $7.45. So a nickel would be worth, keeping it kind of in terms of dollars, that would be worth 0.05. Okay, 0.05 would be how much a nickel is worth. And I know you guys know that, but it's just, we need to kind of flesh it out here because it's not told to me in this problem explicitly. Okay, and then dimes, again, same thing. It would be worth 0.10 or 0.1 dollars, right? A dime's worth 10 cents. Okay, so these amounts that a dime and a nickel is worth are going to be super valuable to me, okay, because that's going to kind of help to add, right? So if he has, right, say he had 93 coins and all of them were nickels, okay, we would do 93 times 0.05, and that would tell me how much money he has, right, total. But again, I don't know how much of each individual coin he has. I just know that the nickels are worth 5 cents, the dimes are worth 10 cents. So then going to set this up, again, tying together the amount that a nickel is worth with the variables, right? So X is the number of nickels, and 5 cents is how much that is worth. So and I'll put the dollar amount there. So 5 cents X plus 10 cents Y. Okay, that's going to be my equation here. 5 cents X plus 10 cents Y equals that total money amount of 745. So what I like to tell my kids here after we establish what these amounts are, right, for nickels and dimes, look, all the dollar amounts are in their own equation together, right? So the dollar amount of the nickels that he has plus the dollar amount of the dimes that he has equals the total amount of money he has. And that makes sense, right? And then the other one doesn't have anything to do with the amount of money that he has. That's just straight up the number of coins. So the number of this type of coin plus the number of this type of coin equals the total. Okay, so those are my two equations. One is like the money, the value equation, and the other one is just the amount of coins that he has. Okay, so that's really tough. That's tough to set up, and especially because they don't tell you that explicitly. But hopefully that makes sense. Okay. And now for this one, thank goodness, we don't have to do all this nasty, crazy stuff up here because we are going to use our buddy Desmos. Okay, so going over here, okay, when I have these two equations, okay, I can just type them into Desmos straight up. So x plus y equals 93. Okay, you're not going to be able to see it at first here. You're not going to be able to see it at first here because it is not zoomed out enough. So if I zoom it out a little bit more, I see my line going through right here. And then I'm going to type my second equation in, so just like it appears. You don't need the dollar signs in there. I don't think Desmos would like that. But 5 cents x plus 0.10y equals the 7.45. Okay, so we see my two different lines there, okay? And again, just like I showed you guys in the graphing video, right? Where these lines cross each other, the intersection point is going to be my solution to the system. Okay, so I see this point right here and it's highlighted for me, 37 comma 56. So let me copy that point over. Okay, so that would be my solution here. Okay, and again, it's not just like normally that would be sufficient, right? Just putting the ordered pair. But again, look at the question: how many nickels does he have? Okay, so again, it's tying this back to how we define the variables. Okay, so all right, again, 37 is my X amount. And what is that? That's the number of nickels right there. And you see we must have 56 dimes, right? So to answer this question that it's asking, how many nickels, so we can say Ike has 37 nickels. And again, if it asked how many dimes, we could say Ike also has 56 dimes. Okay. So again, just checking my answer here, if you did this, right, 37 plus 56 would give you that 93 total. And if you did, like if you had 37 nickels, you did 37 times 0.5, that'd be like $1 or something. And then 10 cents times 56 would be like $5.60. So that would be the total, or that would go with the total. Okay, so both of those check out. Okay, so I'm just going to go through a couple more problems here with you, just setting it up and again solving it in Desmos so it'll be quicker. Okay. So this one says Tiger is sorting his comic books. He has a total of 126 comic books. He had 22 more Viz Media comics than he did Marvel comics. Okay, so how many Viz Media comics does he have? Okay, so again, setting up this equation. Okay, so we have two different amounts here. Okay, so again, it's asking how many Vis Media comics that he has. Okay, so let's just say x equals Vis Media comics. Okay, and y is going to be, we know that, okay, and so again, looking at these two amounts, these two statements that were given, okay, so he has a total of 126 comic books. Again, we don't know how much of each individually that he has, but we know that, right, the amount of Viz Media comics, x, that I don't know right now, plus the number of Marvel comics, y, is equal to that 126 total, okay. So that would be my first statement. That's my first equation, that the total amount of comic books, all right, he has a pile of Viz Media comics, a pile of Marvel comics. We don't know how much of each individual one he has, but the total of them is 126. And so here's something else too, the second statement, okay? He had 22 more Viz Media comics than Marvel comics. Now this is a tricky one, okay? So, right, so just on that statement, which does he have more of? He has more Viz Media comics than Marvel comics. Okay, so here's how I could set this up. Okay, so the Marvel comics. Okay, so he has again a certain amount of those. Okay, so if I took that Y, right? If he has 22 more Viz Media comics than Marvel, right? So if I have a certain amount of Marvel comics, right? If I took that amount and I did plus 22 to that amount. So let's just say he can have more than this. Let's just say he has 10 Marvel comics. Okay, if he has 10 Marvel comics, right, and he has 22 more Viz Media comics than Marvel comics, right, I would do the 10 plus the 22, which would be, he would have then 32 Viz Media comics, right. And again, I don't know exactly how much of that he has right now, right, but if I take that amount and I add 22 to that, right, that's going to give me the Viz Media amount. Okay, so that's a weird setup. Okay, and again, this is the hardest part of this, so it might take some practice. But that would be this equation, right? You take the amount of Marvel comics plus 22 would give you the amount of Viz Media comics. So the hard part is done. I set up my two equations, and so then I would graph these. I would graph these in here. So if I did x plus y equals 126, there would be my first line, okay? And then my second statement, y plus 22 equals x, okay, I have the second line right here. And again, that intersection point is the key spot that's going to show me my solution. So I get 74, comma 52, okay? 74, comma 52. And so again, it's not just giving that. Normally that's sufficient, but again, answering the question how it wants it here. How many Viz Media comics does he have? Okay, so again, it's tying that back to how I define my variables. And so if the x value is the number of Viz Media comics. Okay, so that would be that answer right there. Okay, for that one. Okay, one more here, real quick. Jay is putting a fence around a rectangular garden in his yard. The length of the garden is 4 less than twice the width. That's going to be a complicated one, but we'll get there. The perimeter of the garden is 98 feet. Find the length and the width of the garden. Okay, so again, first thing is defining my variables. What are my unknown amounts? And again, you look at that statement of that question at the end. It wants me to find the length and the width. So let's say x is the length and y is the width. And if you flip them around, you could still get the same exact answer. Okay, so if y was the width, or if x was the width and y was the length, you could still get the same thing. Two statements that I'm given here. Okay, I'm going to deal with that last one. I'm going to go in reverse order. So the second one here. Okay, the perimeter of the garden is 98 feet. Okay, so just thinking about this. Okay, if the perimeter of the garden. Now something that you need here, right? Let me just sketch a little garden here, rectangular garden. So again, you think about a perimeter. Okay, perimeter is, right, the lengths of the four sides added together, right? And so the widths would be, right, the two ones going side to side, and the lengths would be the two that are up and down, right? So if that's the whole kind of dimensions of my garden here, and so if I wanted to find, right, that's what I don't know. I don't know what the length is and what the width is, okay? But if I wanted to add them up to get the perimeter, what I would do is this length plus this width plus this length plus this width, right, would give me that total, right? And a simpler way of saying that would be, right, I have two L's, so two lengths, but again, I'm using x and y here instead. So 2x plus 2 widths, or 2y, equals that 98 perimeter. Okay, so that would be my first equation right there. Okay, 2 lengths and 2 widths is 98. Okay, and I'll show you why we don't want to use L and W here instead. That might be easier, just to kind of tie them together. But with Desmos, we do want to use something different here. Okay, so I'll show you that in a second. But first, we need the other equation. Okay, so the length of the garden is 4 less than twice the width. All right, so think about this. The length of the garden. Okay, just very much so breaking the statement down. The length is x, right? We tied together. Length is x. So length of the garden is, right? Is often that math word that means equals. Okay, so the length of the garden is. So I have x equals 4 less than twice the width. Okay, now this is going to be a statement right here that, let me highlight that. And so let's break that down. Okay, 4 less than twice the width. Okay, so I'm going to take that width, right, and I'm doing two things to it. Okay, again, width is y. I did that over here. So again, twice, and so I'm going to go in almost like reverse order here, right? So I have my width, twice the width. Okay, twice the width. What would that be? That would be, right, twice means 2 times. Okay, so 2 times the width. Okay, but it's not just 2 times the width, right? It's 4 less than twice the width. Okay, and we've talked about this here too. That with this statement of 4 less than is actually, right, even though it's at the beginning of the sentence, okay, that actually is going to go at the end of my expression here. So 2y, right, so twice the width, 2y, but then 4 less than that would be that 2y minus 4. Okay, so that is going to be that first equation. And I know that's tricky, but hopefully that helped to see me kind of break it down like that. Now let me show you. I said that you shouldn't use the letters L and W, even though that might be easier. Let me show you why. Okay, is that like that second statement? If I did 2L plus 2W equals 98, Desmos is not going to know to graph that, okay? Because when it graphs something, it's thinking, okay, X and Y, right, with the X-axis and the Y-axis, okay? And you see it gives you this exclamation point. We only support implicit equations of X and Y, okay? So it tells you, okay, to graph this, I need the letters to be X and Y, okay? So that's why I think it's important, especially if you're using Desmos, to get that. Okay, if you're just doing it by hand, then you could use the letters L and W. So now you can see, okay, the exclamation point is no longer there. You might just have to zoom out a little bit, but yes, there's my line right there. And then again, I flipped these around. I did this one first, and that's fine. X equals 2y minus. Okay, so I have that. Okay, and you see I got some nasty decimals here. So when that happens, okay, it doesn't mean it's wrong right away. Just check your equations, make sure you type them in right. And I did. Okay, so that means that I just have some decimal answers. Okay, so just typing in this equation, or so just typing in this answer, I would get 31.33, comma 17.67, just rounding that up. Okay, so again, what does that mean? Tying it together with my variables. That's why I like to do this first, so I always have this to refer back to. Okay, so 31.33, that would be the length, right, because that's my x value in my ordered pair, and 17.67 is my width, or the y value. Okay, so the garden is this long and this wide. Okay, so that's all. I know that's a lot. Thank you for following. That's some systems of equations word problems for you, working through those and using Desmos to help. All right, so thanks for following. See you later.